All right, guys, this is part 2 of geometric sequences. Just a reminder, here's your formula on the left-hand side. If you're looking for the nth term of a geometric sequence, that's going to be a to the first. That's your first term times your common ratio raised to the n minus 1. A to the n is your nth term. A subscript 1 is your first term, and r is your common ratio. So if you remember from part 1, they have asked us to find a to the 7th term, okay? And it may ask you the 8th term or the 52nd term or the 16th term. It doesn't matter, but just in this assignment, in this set of notes, it asks us to find the 7th term. So that's what we're going to continue to do. All right, number 13 is where we finished off. I'm going to skip 14 and 15 just to save time. It's all very much the same. And we're going to pick up with number 16. If you look at number 16, we have 81 divided by negative 243. So if you do 81 divided by negative 243, that's going to give you negative 0.333. So that's going to be negative 1/3. It's better to write it as a fraction. All right, and if you hit in your calculator, if you hit the math number 1 button, it will change it to negative 1/3 so that you can see that. And then if you do negative 243 divided by 729, you're going to get negative 1/3 again. So that tells us that our common ratio is negative 1/3. We're looking for the 7th term. We're going to take the first term, which is 729, times our common ratio, which is negative 1/3, raised to the n minus 1. So n minus 1 over here, n is 7, minus 1 is 6. So that's going to be, make sure you do order of operations. Again, we have to do negative 1/3 raised to the 6th power first. You always do exponents before you multiply. So put this in parentheses because it's negative. So negative 1/3 raised to the 6th power times 729 equals 1. So what does that tell us? That tells us the 7th term in this sequence would be 1. So if I continued this pattern of negative 1/3 times negative 1/3 times negative 1/3, when I got to the 7th term, let's see, there's 1, 2, 3, here's 4, 5, 6, 7. The 7th term would be a 1. Okay? All right, pause this if you need to. We're going to move on. All right, look at example 17. We have 24 divided by negative 12, which would be negative 2. And we have negative 12 divided by 6, which is negative 2. So we have a common ratio of negative 2. Again, it's asking us to find a to the 7th term. We're going to take our first term, which is 6, times our common ratio of negative 2, and raised to the n minus 1, which is 6. All right, so again, take negative 2 raised to the 6th power, times that by 6, your first term, and you get 384. All right, number 18. Number 18 is very similar, except this time look at how it divides. So when it divides here, we're going to have 18 divided by 12. Those are both divisible by 6, and that's going to be 3 over 2 when reduced. If you put that in your calculator, it's going to give you 1.5. 1.5 as a fraction is 3/2. 12 divided by 8, same thing. If you plug that in your calculator, it's going to give you 1.5, but change it to a fraction by hitting Math, number 1 fraction button. If you have a TI 83 or 84, and it's going to give you 3/2. So our common ratio is 1.5 or 3/2. All right, we're looking for the 7th term. We're going to plug in the first term times our common ratio. raised to the n minus 1. 7 is n minus 1 is 6. All right, I'm going to take this and I'm going to do 3 halves in parentheses raised to the 6th power, and then I'm going to multiply that by 8. Okay, and when you do that, you're going to get 91.125. So that would be your 7th term in this sequence. All right, moving on to the last two examples. So this is an example of a word problem or an application problem. It says the table to the left, okay, so the table to the left shows the car's value for 3 years after it's purchased. Write a rule to represent the car's depreciation. All right, so what we need to do is the same thing as what we were doing before. Take this term and divide it by the previous term. If we do that, you're going to get 0.8. If we go from here to here, we get 0.8 again. All right, now what is 0.8 as a fraction? 0.8 is the same thing as 4/5. Again, you can use your calculator to see that. So what we're going to say is that our common ratio is 4/5. And if you remember when we talked about exponential growth and decay, we can tell that this is depreciation because this number is less than 1. And these are just a version of exponential functions. So 4/5 is less than 1. That means it's exponential decay instead of growth. All right, so let's look at our function. So we're going to have a to the nth equals our first term. Our first term here is 10,000 times r is our common ratio, 4/5 raised to the n minus 1. All right, so this is our equation for this table. All right, so B part, or no, sorry, number 20 says, what will be the value of the car after 10 years? All right, so we're going to plug in 10 for n, or the 10th term. All right, because this gives us the first 3 terms. So we're going to say, what is a to the 10th term, or after 10 years? And we're going to take 10,000 as our original cost of the car, times the depreciation rate, which is 4/5, to the 10 minus 1 power. All right, so we're going to do, in our calculator, you're going to take 4/5 raised to the 9th power and then multiply that by the $10,000. And you're going to find out that your car is worth approximately $1,342.18 after 10 years. All right, I hope this is beneficial, and I'll see you next time.